Testing 1, 2, 3. Okay. Testing. How do you like that word? All right, we're talking about and or, and how they play a role in mathematics, and in particular, linear inequalities. X is less than or equal to 10, so we're going to graph this stuff out. That's what we're doing here. And then writing it in interval notation. X is greater than 0. So what we want to do is draw a number line. Try to draw a horizontal number line. Let's put 10 here. Did I already do this problem? Oh, never mind. It was something similar, but we changed it from and to or. And let's just put 0 here on the number line. And let's do this. I think, I'm trying to remember, in the last problem we were kind of using some colors here. And I think I'll do the same thing. Okay, let's look at x is less than or equal to 10. Okay, so let's look at that one. Now it's including 10. Whoa, wrong color. It's including 10. X is less than or equal to 10. So it's everything going off in this direction on the number line. And x is greater than 0. Now we don't include it, so we put an open circle here. And it's everything going off in this direction on the number line. Now we're using the word or. In other words, when we pick a number on the number line, it's got to satisfy both this inequality. Maybe I shouldn't use that color. It should satisfy, right, the x is less than or equal to 10, and it must satisfy x is greater than 0. But in this case, we're using or. And or means it can satisfy both x is less than or equal to 10 or x is greater than 0. Okay? Or it could satisfy both of them at the same time. Yes, or gives you some options. Options, I like options. If I were to pick a number here, let's say -1, -1 is less than or equal to 10. Well, that's true. But -1 is not greater than 0, right? Not greater than 0. But it only has to satisfy one of them. Okay? It only has to satisfy one of them. If I picked a number over here, let's say 20, not to scale, 20 is not less than or equal to 10, but 20 is greater than 0. So you see, it just has to satisfy one of them. Or we could pick a number in the middle, like a 5, and it could satisfy. Look, 5 is less than or equal to 10, 5 is greater than 0, or means it could satisfy both of them. So what does this really mean? Well, this means that every single number on the number line makes that true. In other words, from negative infinity to positive infinity, you see, that's the entire number line. You know, you could say that that is R, all real numbers. All right, let's look at another one here. Okay, so I'm going to kind of start speeding up just a little bit, hoping you're getting this stuff. All right, let's look at this one. We have x is greater than or equal to 10 and x is less than 0. So let's draw our number line. All right, let's plot 0. Just arbitrarily pick some points here. 10. What does this say? X is greater than or equal to 10. Greater than or equal to. So we'll put a solid dot, and it's greater than or equal to. So everything going off in that direction. X is less than 0. Right, open circle. Everything going off in this direction. Now, we're using the word and. And meant what? Well, it meant it's got to satisfy both this inequality and this one. Well, there isn't any numbers that you can pick that will satisfy both of these, you see. let me go ahead and, right, so it's everything in this direction, and we put a solid dot because we include it and everything in that direction. So you see that? There isn't a number that we can pick that's in this interval that satisfies both this inequality and this inequality. Okay? And obviously, like 5 is not greater than or equal to 10, and 5 is not less than 0. So you see, that's the reason that's not even included. So what's going on here? Well, because the word and means they don't intersect. In other words, they don't have anything in common. This interval does not have anything in common with this interval over here. What does this mean? This is the, remember this notation? Let me go back to black. Remember this notation where we wrote curly brackets and then we wrote some number in here? Well, guess what? There is no number in there. There's nothing. Okay? There are no numbers we can put in this set that satisfies, you know, both these guys. So this set is called, we give it a name. Actually, there's a symbol, looks like that, called the empty set. Right? This is known as the empty set, or the null set, or the null set. Okay? Or the null set. We got time for another one? Yeah, we got time for another one. Let's take a look at this one here real quick. X is something. I don't know. X is greater than 10, or X is less than 0. Did we already do this? No. X is greater than 10, or X is less than 0. No, I don't think we did this problem. No. So we're just kind of going through all the possibilities here, and I'm attempting to draw straight lines, and it's not working out. Here's 10, and we'll just arbitrarily say this is 0. Okay? So in this one here, X is greater than or equal to 10. We put a solid dot. Right? Everything going in that direction. X is less than 0, open. Right? Because that inequality doesn't include it. Now look at here. We're using the word or. Or means that it can be true for either this inequality or this inequality here. See that? Or. Okay. And let's go ahead and write this in interval notation. 0, it doesn't include it. And let's use a symbol here you may not have seen. That's called the union. The union. And this goes from 10 to infinity. So you see, that is the interval. This is known as the symbol union. You're unioning, you're uniting both of these sets. Uniting both of these sets. Okay, interval notation. Yeah, so that's pretty much, is that pretty much it? Or are we gonna work some more problems? Okay, that's it for this video. I'll see you in the next one.